Okay guys, we're on day 2 of our cold day, and today we're going to talk about the addition rule, and specifically we're going to work on two-way tables. So in the title of your notes you want to have addition rule and two-way tables. I want to just review with you what the addition rule is, and the addition rule has the keyword or. And so we talked about something called mutually exclusive events yesterday. And mutually exclusive events is when two events can't happen at the same time. In that case, you don't have to worry about that subtraction of both of them. You just add the two events to happen. What's the probability that you will go to St. Cloud State or UMD? You can't go to both, so you can't subtract anything from that we talked about yesterday where we had to subtract. But if there's not a mutually exclusive event, then you do have to subtract that both. And we practiced that yesterday in the notes. We just didn't define it as well as we have here. So here's just a more concrete way to state it: mutually exclusive events versus non-mutually exclusive events. And just a friendly reminder that mutually exclusive events means they can't happen at the same time. Again, an example of two mutually exclusive events would be attending St. Cloud State and then also attending UMD. You cannot attend both of those colleges at the same time. Non-mutually exclusive events would be something like majoring in physics and going to St. Cloud State. You can do that at the same time. All right, let's get right to the examples. What I want you to do right now is I want you actually to copy down this table right here. So we have two genders. We have female and male, and the percent of the time that student washes hands after using the bathroom. So from 25 to 49, 50 to 74, 75 to 99, and 100% of the time. So the first thing that you should be recognizing, and again, I want to just interject here, I am going to go fast, so it is your job to pause when needed. Okay, so the first thing you should notice is we are missing totals. You need to fill in totals always if you don't see them. So I'm going to do that right now. The total number of people who wash their hands between 25 to 49% of the time is 1. The total between 50 to 74 is, let me see, I can't see, is 2. The total here is 11, and then we have 14. We also have to figure out how many females we have and how many males we have. So we have 2 plus 6 is 8, okay, and 8 plus 13, well, that's 21. And then we have 1 plus 5 is 6, and 6 plus 1 is 7. And then down here, we have a grand total of 28 students. So we're going to write that right here. Okay, now we're going to ask different questions based off this two-way table. So the first question is, what is the probability the student is male? A friendly reminder that probability is we're looking at the success and how many there are of that success. So the success right here is being a male. How many males do we have? We have a total of 7. We don't care about them washing their hands right now. We just want to know how many males do we have. So in this case, we have 7 total males. Out of how many total outcomes? Well, there's 28 total students. So 28. Now we want to know the probability the student did not report always washing his or her hands after using the bathroom. So did not report always washing his or her hands after using the bathroom. So who didn't always wash their hands? Well, these people, these 14 people always washed their hands, which means these 11 people didn't always wash their hands. These 2 people didn't always wash their hands, and this 1 person did not always wash their hands, which gives us a total of 14 people who didn't always wash their hands divided by a total of 28. So probability is, what is our success? Our success here is not always washing our hands. How many are there of them? There's 14 divided by our total outcomes, which is 28 total people. Okay, next, the student is female and reported washing her hands after 75 to 99% of bathroom visits. Well, now they're giving us some different information. We know something. The student, oh, forgive me, we don't know something. We want to find the probability that the student is female and reported washing her hands 75 to 99% of bathroom visits. So we need to look for that. The success is that they are female and that they wash their hands 75 to 99% of the time. So where is that? Well, females are here. 75 to 99% of the time is here. So there's 6 females or 6 people who are females and also wash their hands 75 to 99% of the time. That was our success. 6 of them out of 28. Our next one, the student reported washing his or her hands after 75 to 99% of bathroom visits or is male, okay? So now we have to use these rules. Really, all you have to remember is this bottom rule. And then if it can't happen both at the same time, you just don't subtract anything. You get to use your notes either way, so that should help as well. The student reported washing his or her hands after 75 to 99% of the time or is male. So let's start with first the 75 to 99% of the time. How many are there 75 to 99% of the time? There's 11. So 11 divided by 28 plus how many males do we have? We have 7 total males. 7 divided by 28. Now we have to say, can it happen at the same time? Can we have males who also wash their hands 75 to 99% of the time? So it's both happening at once. And here I see 5 males who are, or 5 people who are males and also wash their hands 75 to 99% of the time. Both of these 2 events happening here, 75 to 99% and being male. So we have to subtract that then. Minus 5 divided by 28. When we add fractions and we have common denominators, we just keep that denominator. We add up 11 plus 7, and then we subtract 5. And that gives us 13 divided by 28. Okay, now what I want you to do is I want you to open up the PDF and get started on the homework. The homework is all based off these 2 tables. You can stop the video right now and try the homework, but what I'm going to do actually is I'm going to start talking you through the homework. So your whole goal today is using that addition rule, which we did in part D, and also just knowing how to read the two-way table and what is the question asking. I've gone through all the notes that I need to. I've talked about two-way tables. I've talked about the addition rule. You can go ahead. You can open up worksheet 3 in Schoology and you can try it. Now, if you're struggling, I'm going to talk you through it right now. Okay, so come back to this video if you're struggling. I'm not going to do the whole worksheet. I'm just going to give you helpful hints. Number 1, a standard deck of playing cards with jokers removed consists of 52 cards and 4 suits. Clubs, diamonds, hearts, and spades. Each suit has 13 cards with denominations ace through king. The jack, queen, and king are referred to as face cards. Imagine we shuffle the deck thoroughly and deal 1 card. Let the event J equal getting a jack and event R getting a red card. Construct a two-way table that describes the sample space in terms of J and R. Okay, so this is what we want to think about. We want to think about, well, how many jacks do we have total? So if you think about a deck of cards, how many jacks do we have? We have 4 total jacks. So I like to fill in my totals first. I'm going to have to write a little smaller here. We have 4 jacks, and then no jacks. Well, if we have 52 cards total, and we have 4 jacks, that means we have 48 that are not jacks. Now we have to talk about the red cards versus the non-red cards. Okay, so we're going to talk about the totals here now. Again, always fill in your totals first. So how many red cards do we have? Well, we have red cards that are hearts, and we also have red cards that are diamond. So 52 divided by 2 gives us 26 total cards that are red, and then 26 total cards that are not red, which gives us a grand total of 52, which I'm going to write down here. Well, now we have to think, okay, well, how many red cards are jacks? So that's going to be half of them. So that's 2 red cards that are jacks. We have 4 total, which means we have 2 red cards that are not jacks. Okay? I'm sorry. We have 2 jacks that are not red. Excuse me. Now, we can think about it this way. If we have 26 total red cards and 2 of them are jacks, 26 minus 2 gives us 24 that are not jacks. Again, over here, same thing. We're going to have 24 that are not jacks and that are not red. Okay, so this one is 24, right? That are not jacks but are red. How did I get that? Well, I know that there's a total of 26 red cards. I know that there was 2 jacks, and that leaves us with 24 left over because 2 plus 24 has to equal 26. This is this column's total right here. This is this row's total, so on and so forth. Okay, I'm going to do all of number 1 with you just to get you guys started. Find the probability that we get a jack card. So how many total jacks are there? Well, there's a total of 4 jacks. Divided by how many total cards? 52 total cards. Find the probability of having a red card. Okay, well, how many red cards do we have total? We have 26 red cards divided by 52 total. Find the probability that we have a jack card and it's also red. Okay, there are 2 jack cards that are also red. So that's 2 divided by 52 total. And now we have that addition rule, jack or red. So I'm going to start with the jack. How many jacks are there? There's a total of 4 jacks. So that's 4 divided by 52. Plus, now how many red cards do we have? We have 26 red cards. So that's 26 divided by 52. Now how many are jack and also red at the same time? There are 2 cards that are jack and red at the same time. So when we see that or, what do we learn again? We have the probability of a jack, 4 out of 52, plus the probability of a red, 26 out of 52, minus the probability of both of them happening. That's 2 out of 52. 4 plus 26 is 30. 30 minus 2 is 28, so 28 divided by 52 is my final answer for number 1. Number 2, I'm going to let you go on that one. The big thing is you just have to fill in your totals. Who are the individuals? It's the Senate members from 2008. What are the variables being measured? Well, the variables being measured are their status, their political status, Democrats or Republicans, and their gender. Okay, so number 3, I'm going to help you fill out this table, and then you can fill out the rest. A school team consists of 20 members. 10 of the members are seniors, with an equal number of males and females in the class. There are 6 juniors, 2 of them of whom are female. 3 of the sophomores are males. Complete the table at the right. Okay, so this is like filling in a little puzzle, right? We know that there's a total of 20 members, so I'm going to put that 20 total down here. Then next what it says 10 members are seniors. Okay, so I'm going to look at the seniors. The total number of seniors is in this column right here. So I'm going to put 10 right here. And then it says an equal number of them are males and females in the class. So that means of the 10 seniors, we have 5 that are male, and then we have 5 that are female. All right. So we've filled in a lot so far. Let's keep going. There are 6 juniors. Okay, so we know in the junior class, we're going to put down here 6 total juniors without regards to their gender right now. Then we know 2 of whom are female. So we're going to put 2 here. Well, if we know we have 6 total juniors and 2 of them are female, that means we have 4 that are male. All right, 3 of the sophomores are male. So I'm going to go to the sophomores right now, and I'm going to put 3 right here for the males. We need to figure out how many are female. Well, how are we going to do that? We know we have 20 total students. 10 of them are seniors. 6 of them are juniors, which leaves us with 16 total. Well, we need 20 total, so it has to be 4 right here. Okay? If there are 4 total sophomores and 3 of them are male, that means we have 1 female who's a sophomore. We're going to add up our totals over here. 3 plus 4 is 7. Okay? 7 plus 5 is 12. So we have 12 total males. We have 20 total. That means we have 8 total females. All right. I filled out the table with you. You can try to answer these questions, and again, we'll go through questions tomorrow. I'm going to have you guys try the rest, and again, why don't I actually do the dice with you guys? This is where you want to fill out the table, okay? And we're talking about the sums. So I have 1, 2, 3, 4, 5, and 6. And again, here I have 1, 2, 3, 4, 5, and 6. Why am I filling this out? I'm filling this out because two things are happening. 2 dice are being rolled, right? It says the probability of a sum of a 6 or a 7 or an 8. So how am I going to fill this table out? I want to fill it out with the sums, right? So a 1 and a 1 together is 2. A 1 and a 2 together is 3. A 1 and a 4 together is 5. A 1 and a 5 together is 6. And a 1 and a 6 together is 7. And we keep going, right? So here, a 2 and a 1 together is 3. A 2 and a 2 together is 4. And you keep going, filling that table out. A 2 and a 3 together is 5. So on and so forth. Hopefully that makes sense. And again, I'll answer any questions tomorrow. Let's fill out this last two-way table together. The Smithsonian Museum accounts for many of these tourists. There's 16 million that come a year. The probability that a tourist will go to the National Museum of Natural History is 0.44. The probability that they'll go to the Air and Space Museum is 0.38. The probability that they will go to both of them is 0.30. Okay, so how would I fill out a two-way table for this? I'm going to put Air and Space as Air and Space like that, or not Air and Space, right? What else is happening? They're going to the Museum of History, right? So they're going to Natural History. I'm going to go like that. Or not Natural History. I'm going to divide it so it looks a little nicer. And the bottom should be our total. Now, the tricky part is they give it to you as a decimal. Well, one thing you need to know when they give it to you as a decimal, that our grand total then will be a 1, because there's a 100% chance of everything happening here. It says the probability that a tourist will go to the Natural History Museum is 0.44. So natural history right here, I'm going to put 0.44. Okay. The probability that the tourist will go to the Air and Space Museum is 0.38. So that goes right here. The probability that they'll go to both is 0.30. So both Air and Space and Natural History Museum is 0.3. Now we can figure out everything else just using a little puzzle. We know that this row has to equal 0.44. So 0.44 then minus 0.3, right? That gives us 0.14. Because 0.3 and 0.14 give us 0.44. How did I know 0.44 goes here? Because they say the probability of going to the Natural History Museum is 0.44. That's this row right here for our totals. Okay, now we also know, right, that the probability of going to the Air and Space Museum is 0.38. Well, the probability of going to both is 0.30. Okay, so not going to the Natural History Museum has to be 0.08. Why? Because this column has to add up to 0.38. Well, how do I fill out the rest? I already told you that this has to be 1 down here. And we know this is 0.44, so 0.44 plus what number gives us 1? Well, in order to figure that out, we do 1 minus 0.44. And that gives us 0.56. If I know this is 0.56, I can take 0.56 minus 0.08 to give us 0.48 here. I now can add 0.48 plus 0.14 to give us 0.62 right here. Our table's filled out, and now you could answer the questions and just using decimals. Try it on your own, and I'll answer any questions tomorrow. I'm done for the day, guys. You guys know what you need to do. If I'm not clear, you can always email me. Thanks so much, and have a great day.